Hey guys, this is Mr. C, and in this video we're going to be looking at systems of inequalities in standard form. These are a little bit tougher than the ones that are in slope-intercept because we are now dealing with boundary lines that are in standard form, so we're going to have to be very careful when we are working these out. All right, so here we go. Okay, so problem number one. First thing you want to do is label your inequalities 1 and 2. And now we have to figure out what the boundary lines are. So I'm going to lean on some of the information and the knowledge that I've had before with these inequalities, so that it kind of makes my life easier. So when I'm trying to figure out how to graph the boundary lines, I need to figure out what the slope and the y-intercept are. So I need for both of them M and I need B. M and B for both of them. Okay, so I'm going to put this here because before I even graph this, I'm going to figure out what that stuff is first. So that we know that for a line in standard form, we know that the slope is negative a over b, and we know that the y-intercept is c over b. Okay, so those are things we know. We've already gone over that, and so we're going to use that knowledge to help us out. So for equation number one, for inequality number one, the boundary line slope, I have an a value of 1, I have a b value of -3, and I have a c value of 0. So that tells me right now that my slope is going to be -1 over -3, which is going to simplify to +1/3. So my slope for this one is going to be +1/3. Now I'm going to write that down up here. Okay, my y-intercept is going to be c over b. So that's going to be 0 over -3, which is going to simplify to 0. So I'm going to put a 0 here for that y-intercept. For the second one, okay, that's got an a, well, it's a different a, b, and c values, so I've got to kind of start over here. So the a value is going to be 2, the b is 3, and the c is -3. All right, so for that one, my slope is going to be negative a over b, which is going to give me 2/3. So -2/3 is my slope. My y-intercept is going to be -3 over 3, which is going to simplify to -1, just like that. All right, so each one of these, I'm going to have to kind of burn one of these whiteboards there. Okay, and here we go to graph. Now, we got 2 of them. So my first boundary line is going to have a y-intercept of the origin, and it's going to have a slope of 1/3, so up 1 over 3, up 1 over 3, back 3 down 1, back 3 down 1. Okay, it's going to be a solid line, boundary line, because you have the little equals here. So we're going to graph a solid boundary line like this. Okay, and now we need to decide which way to shade. Do we shade above or do we shade below? So we need to pick a test point. And the easiest test point to pick is the origin, but the line goes through the origin. The boundary line does. So I can't pick the origin. So I'm going to pick this one. I'm going to pick 1, 1 and see if it works. So 1, 1, I'm going to test in this inequality. So we're going to test 1, 1. So 1 minus 3 times 1. 1 minus 3 times 1. Is that less than or equal to 0? Okay. Is 1 minus 3, because 3 times 1 is 3, less than or equal to 0? Is -2 less than or equal to 0? Well, that's true. -2 is less than or equal to 0. So we're going to shade above this boundary line right there. So when I shade, I'm going to be very careful here, and I'm going to use a different color for each one. So I'm going to shade this one in red above this boundary line, because my test point said that all of those points are solutions to the first one. Now, it's also going to be a good idea for me to go ahead and label that boundary line as the first one. Okay, here comes my second one. My second one has a y-intercept of -1, and it's got a slope of -2/3. I got to be careful because I put that test point on there, and it's looking like a point on this, possibly on the second line, but it's not. I need to go down 2, 3 to the right, down 2, 3 to the right, down 2, 3 to the right. So these can get kind of messy in a hurry. 3, 3, okay. So I'm going to go ahead and graph that, and it's going to be solid because it's not strict. And this is my second one. So here's my second boundary line. Now, I can use the origin now to test and see if I shade above or below for this one, because this boundary line doesn't go through the origin. So when I use the origin, I basically set the whole left-hand side equal to 0. So for the second one, this is for the first one. For the second one, is 0 less than or equal to -3? And 0 is definitely not less than -3. That's false. 0 is greater than -3. So since that's false, for the second one, I would not shade the side with the origin, which is this side. I'd shade the other side. And I'm going to shade that in, I think we're going to go ahead and use blue here. And I'm going to shade below the second one. So what happens is your coordinate plane got split up or partitioned into 4 pieces. 1, 2, 3, 4. One of those pieces isn't shaded at all. These points are not solutions to either of these. The red ones are all solutions to the first one, all of these, and the blue ones are all solutions to the second one, and the part where it's shaded twice are solutions to both of them at the same time. That's the section that needs to be shaded twice or darker than the other ones. So that is our region of solution, our solution region right there. All right, let's try another one. This one, again, I'm going to do the same exact thing. I'm going to label them 1 and 2. Okay, so here we go. 1 and 2. All right, so the first one, I need to know a slope, and I need to know a y-intercept. Second one, I need to know a slope and a y-intercept. And so let's go ahead and get a whiteboard and let's figure out what they are. All right, so for the first one, A is 2, B is -3, and C is 6. Okay, so that's going to give me a slope of -a over b, which is -2 over -3, which is actually going to be a positive 2/3. That's what my slope is for the first one, 2/3. My y-intercept is going to be just c over b, which is 6 divided by -3, and that's going to be -2. So I now know the slope and the y-intercept of my first boundary line. My second boundary line, and I can go ahead and do that down here. That's fine. My second one. My A value for that one is 1. My B value is 1. My C value is -3. And so now I'm going to have the slope -a over b, 1 over 1, which is going to simplify to just -1. My y-intercept is again c over b, so -3 divided by 1 is -3, and so that's going to be my y-intercept. All right, so that has helped. So let's see what's going on. So for number 1, I've got a y-intercept of -2, and I've got a slope of 2/3, so up 2 over 3, up 2 over 3. Okay, back 3 down 2, back 3 down 2. And that is going to be, again, a solid line. Okay, that is number 1. Now, do we shade above or below? Well, it doesn't go through the origin, so we're going to use the origin to find out. So for number 1, we're going to test 0, 0, and see what happens. So for the first one, is 0 less than or greater than or equal to 6? Is 0 greater than or equal to 6? That's a false statement. That is false. Since that is false, we are not going to shade the side with the origin. We're going to shade the other side, which is going to be this side. And so this time, let's use green. And we're going to shade this side of that boundary line. All right. Now let's see the second one. The second one has a slope of -1 and a y-intercept of -3. So here's your y-intercept of -3. Slope, down 1 over 1. Now the good thing about these is we don't really need to know where the two lines intersect. All we need to know is the regions where they overlap. So our boundary lines, where they meet, doesn't really matter for these problems. But the shaded regions matter immensely. All right, so let's go ahead and we'll use red for this one. So here we have number 2, right there. Okay, here's the origin. So do I shade above or below? Well, let's test the origin for number 2. Is 0 less than or equal to -3? That is going to be, again, a false statement. 0 is definitely not less than -3. That's false. Since that's false, we are not going to shade the side with the origin. We're going to shade the other side. So we are now going to shade this side. Okay, so what is my final answer for this one? Well, which part got shaded twice? This part right here got shaded twice, and that is my solution region. All right, so we got a couple more here. These two, they can get kind of difficult. Let's see what this one looks like. Okay, this one, again, I have 1, I have 2. And so, again, we need to know the slope and the y-intercept. Slope, y-intercept. All right, so here we go. Okay, so for the first one, we have A is 1, B is 2, and C is -2. So my slope is going to be -1 over 2, which is -1/2. Okay, my y-intercept for this one, my B value, is going to be C over B. So -2 divided by 2 is -1. So that's nice. All right, so let's do the bottom one, the second one. So for the second one, I have an A of 1. I have a B value of -4. And a C value of -2. All right, so my slope for this one is going to be -1 over -4, which is really going to be a positive 1/4. No big deal. My y-intercept is not going to be as fun because -2 divided by -4 is actually going to turn out to be a positive 1/2. That's going to be an issue because I don't like graphing points that are fractions like that on my coordinate plane because it tends to make my lines not so accurate. So we're going to have to deal with that when we get to it. I'll show you how to deal with that when that happens. All right, so let's take a look at number 1. Number 1, we have a y-intercept of -1, a slope of -1/2, so down 1 over 2. Again and again, back 2 up 1. And so we're going to get this boundary line for the first one right here. It's solid again. All of these are solid in these examples. So this is the first one. Shade above or below? Well, let's look at the origin. Is 0 less than or equal to -2? No, 0 is greater than -2. So we need to shade below that line here. So I'm going to shade below. I'll use red to shade below for this one. Okay, now for the second one that's going to give us all this trouble. I know what the slope is. The slope is 1/4, but I'm not quite happy with this 1/2 right there for the y-intercept. So what I really need to do is I need to plug some numbers in for x and then see if I get a y value that is an integer. So let's try for the second one, let's try to plug in 0 for x. So this is boundary line number 2. So I'll make a little table of values. And so here's what I'm looking at. I'm looking at x minus 4y equals -2. That's really what I'm looking at there. That's the boundary line for number 2. So if I plug in, let's just say a 0 for x, all right? And I'll even do it like this right here, because sometimes you have to do it like this. So if I plug in a 0 for x, and let's do a y there. If I plug in a 0 for x, I'm going to get 0 minus 4y equals -2. Okay, so what would the y value be after you solve that? So that, again, may entail us to have a whiteboard again. 0 minus 4y is equal to -2. So -4y is equal to -2. And if we divide by -4 on both sides, we basically get the y-intercept just like we had it before. Y is equal to 1/2. That's not doing me a whole lot of good because I didn't want a fraction, I wanted an integer. So this time, let's try 2 for x and see what happens. So now I want 2 minus 4y is equal to -2. So let's try that. 2 minus 4y equals -2. Subtract 2, subtract 2. -4y is equal to -4. And it looks like now, if I divide by -4, y is equal to 1. So it looks like when x is 2, my y value, which is 1/2 there, is 1. So what that tells me is the ordered pair 2, 1 is on this boundary line, and that's exactly what I needed. I needed a point on the boundary line. So 2, 1 is on there. Now I can use my slope to get all my other points. So up 1/4, down 1, back 4, 1, 2, 3, 4, down 1, 1, 2, 3, 4, and it looks like this is my boundary line for the second one. So when your slope and when your y-intercept doesn't come out to be a nice integer, this is basically what you have to do. So this is good that you're seeing this, because it's going to happen. All right, so here's my second one finally. So which way am I going to shade? The origin's right here. Okay, so is 0 greater than or equal to -2? That is true. 0 is definitely greater than or equal to -2. So the origin works. So I'm going to shade everything below that boundary line. And I'll use blue this time. And so for boundary line number 2, all of this is going to get shaded. And it looks like my region of overlap is this region right here. All of that got shaded twice. Okay, last one we're going to do here for these, because these are a little tougher, so we can't do as many, is this one. So here we go for this one. So we got one there, and here's the second one. All right, so again, I want a slope, and I want a y-intercept if that's even possible. Well, it's definitely possible. It just may not be a number we like. So let's find out what they are. All right, so turn that around. Okay, so for the first one, A is 2, B is 3, and C is 3. Okay, that's going to give me a slope of negative A over B, 2/3, so -2/3. That's fine. A y-intercept of C over B, 3/3, which is 1. So that one looks pretty good. The second one, I don't think that's going to be as good. For the second one, A is 1, B is -4, and C is -10. So we're actually going to get the slope of this one is -1 over -4, which it looks like it's going to be, for this one, -4. So it looks like it's going to be a positive 1/4 for that slope. But for the y-intercept, that's going to be actually -10 over -4, which is going to reduce down to 5/2, which again is a fraction, and we're not too happy with fractions. So we're going to have to deal with that. We can deal with that. All right. So let's do this. Let's graph the first one. B is 1. Slope is down 2 over 3. Okay, this will be the easier one to do first. 3 up 2. Okay, it's a solid line. All right, so that's our first one. Okay, shade above or below, is 0 greater than 3? And the answer is no, 0 is not greater than 3. So therefore the origin is not going to work, and we need to shade above. So this time we'll use purple for that. We'll shade above this boundary line because the origin does not work. Or it's not a true statement. All right, now let's look at this nasty one down here. For this guy, and we were talking about for the second one, we were talking about x minus 4y equals -10 for the boundary line. We could do like we did before, where we sit there and plug values of x in until we get one where the y value is an integer. Sometimes you can kind of luck out and you get one. So let's say that we plug in a 2 for x, and let's see what happens. So if x is 2, if x is equal to 2, here's what y is going to be. 2 minus 4y equals -10 minus 2 minus 2. So -4y equals -12. Ooh, this looks good. Divide by -4, divide by -4. So therefore y is going to be equal to 3. So it kind of lucked out that the point 2, 3 is on this boundary line for number 2. The 2, 3 is on there. Now, how did I know that? Because I've worked so many of these that I kind of have a feeling for which ones are going to work and which ones aren't. But if you don't have a lot of experience, then you have to sit there and plug numbers in until you get one that's a good point. Now I can use my slope, up 1 over 4, to get all the other points. Up 1 over 4, back 4 down 1, back 4 down 1. Connect my dots, like so. Okay, and now we're going to determine which side to shade. So this time, shade above or below. Well, let's look at the origin right here. Oh, and by the way, I need to number that. This is boundary line number 2. All right. So the origin is right here. Is 0 greater than -10? And the answer is yes. The 0 is definitely greater than -10. So we are going to shade the side of the origin, and we're going to shade below that second boundary line like this. All right, so which part got shaded twice? That would be this part right there. That region's shaded twice, and that's your solution region. So the first 2 of these weren't too bad, but the second 2 were kind of rough because the boundary lines weren't easy to graph, but could they be done? Yes, they can be done. Just got to be persistent. So that's it for Systems of Inequalities in Standard Form. Remember to like my video and subscribe to my channel if you haven't already. We'll see you guys later. Bye.